Good evening, class. Today we're going to go ahead and discuss section 6.6, ratio and proportions, part 1. Uh, Essentially what it is a comparison of two like or unlike units. Now we've seen this before, but it wasn't called a ratio, it was called a fraction. So let's just do a quick review of that. So for example, remember when we had, let's say we had a fraction that we had 4 over 8. So the first thing for us to do was to go ahead and reduce that. So if we reduce that, we would put an equal sign in there, and we would reduce by the greatest common factor. In this case, the largest number that is divisible into 4 and 8 would be 4. So 4 goes in there once, 4 goes into 8 twice, and it was 4/8 is equivalent to 1/2. Well, the problem was, how come these two ratios, or in this case fractions, are equivalent if the numbers are not the same? Well, it's not because their value is equivalent, it's because of their proportionality. And we're going to discuss that a little bit later on. Now, as far as we know this is 4 times as much as this number, and this is 4 times as much as this number. Alright, so in that case, we knew those as ratios. So that ties up to what we're going to do next, which is called your proportion. Your proportion is essentially the equivalent relationship of two ratios. So going back to this previous one, we wanted to know whether these two are proportional or not. And the way you would test that is by multiplying diagonally. So you get the numerator from one of the fractions, or in this case ratios, and you get the denominator. That should give you the same thing if you were to do the opposite. If you were to get the denominator of the other one and the numerator of the other one. So let's test it. 4 times 2 and 8 times 1. If we multiply those two, 4 times 2, that'll give us 8. And 8 times 1, that'll give us 8 as well. Since both of them are equal to each other, we call that proportion, or that they're proportional to each other. This is the reason why we would put an equal sign. It's not because of the value that was equivalent, it's because they're proportionally equivalent. Alright? So in a nutshell, that's what we covered back then when we were dealing with fractions. Now what we're going to do is get more into the technical part of it, and then we'll take a look at some applications here. So keeping on with this theme that we were talking about, multiplying diagonally and see if they're equivalent. If you take a look at part 1 of worksheet 6.6, if you don't have it, make sure you print that out. So what you have there is you have a couple of proportions right there they want you to solve. Notice that you either have missing either a numerator or a denominator. It just depends on what you're dealing with. But it's the same idea. So in this particular case, what you're going to do is go ahead and multiply 2 times 10, and multiply 5 times x. Now it doesn't matter where you place these things, as long as you place them either to the left or to the right, as long as you understand that that's what we're going to do with these things. So once again, get the numerator, multiply it times this denominator, 2 times 10, and do the opposite, 5 times x. In other words, get this denominator, multiply it by the numerator. So what we're going to do now is we're going to calculate this. Remember, we're missing the value for this numerator to make it equivalent. So 2 times 10, that'll give you 20. 5 times x, that'll be 5x. So essentially what you have here is an equation. And we know how to solve these. These are pretty simple to solve. All we would have to do next is just go ahead and solve for x. So we would divide both sides by 5. So your final answer here is x equals 20 divided by 5 will be 4. So your answer is 4. Now test it like we tested that first example right there. Substitute the 4 in there for your numerator and see if it gives you the same thing. Well, remember, we multiplied 2 times 10, which eventually gave us 20, and 5 times x. Now we know what x is. X is 4, so 5 times 4 will also give you 20. Since both sides are going to give you the same thing, that means that this answer is correct. And that's the way you test it. Let's try another one. So what we're going to do now is we're going to multiply the numerator times the denominator. Once again, it doesn't matter where it is, as long as you put it on there. And we're also going to multiply this denominator times this numerator. So we're going to multiply 33 times 9. So once again, that's what you have to do with all of these. You're going to have to go ahead and do some type of division here. Multiplication and then division. So here we end up with 297. 33 times 9. Alright, so same thing as before. We're going to go ahead and divide both sides by 11. And here we divide 297 by 11. And once again, you could do this manually, or you could go ahead and do this on your calculators. That'll end up giving you 27. Alright. So once again, nothing very hard here. It's just a matter of following this pattern. And let's do one more here. So the next one that we have here, and by the way, when you get your answers, it doesn't always necessarily have to mean that you're going to get whole numbers. So it depends on the problem that you have. So this last one right here, we're going to do the same thing. We're going to multiply it diagonally. So this will be 6x, and 1 times 56 will give you 56. Unfortunately, when we go to divide it, 6 is not divisible by 56. So the only other thing that we could do is we could go ahead and reduce it. So we could reduce it by 2. So if we reduce it by 2, this is going to be 28 over 3. So you can leave your answer as an improper fraction like this, or you could change it to a mixed fraction, but more than likely you don't have to. That should suffice, 28 over 3. Again, you don't have to do a mixed fraction on this because it'll look kind of weird. But just keep that in mind, that you could either have whole numbers, you could have fractions, you could have improper fractions, or you could have decimals for your answers here. Alright, so this concludes the technical part of 6.6. Next, we're going to take a look at the applications.